In part A, we're asked to solve 14n is greater than 11n plus 6. Well, let's start by moving the 11n over to the other side. So 14n take away 11n is equal to 3n, and so we're left with 3n is greater than 6. Now to find the value for n, we can divide both sides by 3, and so we end up with n is greater than 2, which we can write down in our answer box. Now in part B, we need to show the set of values of x for which minus 2 is less than x plus 3 is less than or equal to 4. Well, now let's start by taking 3 away from each term in order to find the set of values for x. And so minus 2 take away 3 is equal to minus 5, x plus 3 take away 3 is equal to x, and 4 take away 3 is equal to 1. Now we need to think about how we're going to represent this on our number line. And so on number lines, when we have less than or greater than, we have an empty circle. But if we have less than or equal to, or greater than or equal to, we'll have a coloured in circle. So now let's see how this looks when we draw it on our number line. Well, minus 5 is less than x, and so we'll have an empty circle. Now when we draw the line all the way to 1, x is less than or equal to 1, and so our circle at 1 would be coloured in. And so we've now correctly shown on our number line the set of values of x for which minus 2 is less than x plus 3 is less than or equal to 4. Now this question is worth 5 marks. We get the first mark in part A for saying 3n is greater than 6. And we get the second mark in part A for getting the correct answer that n is greater than 2. Now we get the third mark in part B for drawing a line from minus 5 until 1. We get the fourth mark for having an empty circle at minus 5. And the fifth mark for having a coloured in circle at 1. And so we've now achieved the full 5 marks needed in this question. In this question, we're asked to draw the graph of y equals 2x minus 3 on the grid below, for values of x from minus 2 until minus 4. Now let's start by considering what the line y equals 2x minus 3 really means. We can recognise that this is in the form of y equals mx plus c, and so we can see that this line is a straight line graph. Now the minus 3 suggests that we have a y-intercept at the point 0, minus 3, and the 2x suggests that we have a positive gradient of 2. Now let's see how we represent this on the grid below. We'll first draw a point at our y-intercept, and so we've now drawn a point at 0, minus 3. Now if we have a gradient of 2, that means the change in y divided by the change in x is equal to 2. But now this is where we need to be careful. This means that for every one value of x to the right, we go up by 2 values of y. And now to go one value of x to the right, we'll go from 0 to 1. And now to go up by 2 values of y, we'll go from minus 3 to minus 1. And so we can see that our next point on our line lies at the point 1, minus 1. Now it's really important to be careful of the scale of our axes. Even though we have a gradient of 2, this doesn't necessarily mean that we go 1 square to the right and 2 squares up. We have to go 1 value of x to the right and go up by 2 values of y. Well, now we can apply the same process between the x values of minus 2 until 4. And now that we've drawn all of our points between minus 2 and 4, we can join these points together. And so we've now successfully drawn the graph of y equals 2x minus 3 for values of x from minus 2 until 4. Now this question is worth 3 marks. We get 1 mark for drawing a line between x is equal to minus 2 and x is equal to 4, and not going beyond these limits. We get the second mark for a line with a y-intercept at 0, minus 3. And we get the third mark for a line with a clear gradient of 2. And so we've now achieved the full 3 marks needed in this question. In this question, we're told that Hannah is planning a trip for 195 students. She asks a sample of 30 students where they want to go, and each student chooses one place. Now the table below shows information about her results. And now we need to work out how many of the 195 students you think will want to go to the theme park. Now looking at our table, we can see that 10 students out of a sample of 30 students want to go to the theme park. And now to find how many of the 195 students you think will want to go to the theme park, we need to multiply both the numerator and the denominator by 6.5. Because 30 multiplied by 6.5 is equal to 195. And so we'll end up with 65 out of 195. And so we've used the fact that 10 students out of a sample of 30 students wanted to go to the theme park, and so using this multiplier of 6.5, we found that 65 students out of the 195 students will want to go to the theme park, and so we can write down our answer of 65. Now we need to state any assumption that we made and explain how this may affect our answer. Well, now we assumed that this sample of 30 students represents everyone in the population of 195 students. And so we can write down that we assumed that this sample is representative. And so if the sample wasn't representative, our answer to part I would be wrong. Now this question is worth 3 marks. We get the 1 mark for doing 10 multiplied by 6.5 in order to find how many of the 195 students you think will want to go to the theme park. We get the 2nd mark for getting the correct answer of 65. And we get the 3rd mark for stating our assumption that the sample is representative, and for saying that if the sample wasn't representative, our answer to part I would be wrong. In this question, we're told that a container is in the shape of a cuboid. The container is 2/3 full of water. We're also told that 1 cup holds 275 milliliters of water. And we need to find the greatest number of cups that can be completely filled with water from the container. Well, we can start by finding the volume of the cuboid. And so the volume of the cuboid would be equal to 30 multiplied by 6 multiplied by 19, which is equal to 3,420 centimeters cubed. But we're told that 1 cup holds 275 milliliters of water. We want to be working in the same unit throughout the question. 1 centimeter cubed is equal to 1 milliliter. And so if the volume of the cuboid is equal to 3,420 centimeters cubed, the volume of the cuboid is equal to 3,420 milliliters. But we need to find the number of cups that can be completely filled with water from the container. And the container is only 2/3 full of water, and so we need to find the volume of water in the container. And so 2/3 multiplied by 3,420 is equal to 2,280 milliliters. And so we can see that in the container we have 2,280 milliliters of water. And now the next thing that we need to do is to find out how many cups are in 2,280 milliliters of water. Well, we know that 1 cup contains 275 milliliters of water. And so to get from 275 milliliters to 2,280 milliliters, we multiply by 2,280 over 275. And so doing the same thing on both sides, 1 multiplied by 2,280 over 275 is equal to 8.290. So in 2,280 milliliters, we can fill 8.290 cups of water. But we need to find the greatest number of cups that can be completely filled with water from the container. So if we have 8.29 cups, we can see that the number of cups that can be completely filled with water from the container is just equal to 8. And so we've now found that the greatest number of cups that can be completely filled with water from the container is equal to 8. Now this question is worth 4 marks. We get the 1st mark for finding the volume of the cuboid. We get the 2nd mark for finding 2/3 of this volume. We get the 3rd mark for finding the number of cups in 2,280 milliliters. And we get the 4th and final mark for our correct final answer that the greatest number of cups that can be completely filled with water from the container is equal to 8. And so we've now achieved the full 4 marks needed in this question. In this question, we're told that ABC is a right-angled triangle. And we need to calculate the length of AB, giving our answer correct to 2 decimal places. Now when we have a right angle triangle, we can use trigonometry to find the length of missing sides. Now we have the angle 38 degrees, and so we can label each side. We can say that line AC is equal to the hypotenuse. We can say that the line BC is equal to the adjacent side, and we can say that the line AB is equal to the opposite side. Now let's look at the values that we know and the value that we want to find out. We know the value of AC, and so we know the length of the hypotenuse. And we want to find the value of AB, and so we want to find the value of the opposite side. Now let's think about the trigonometric function that we can use that will incorporate the opposite side and the hypotenuse side. We know that sine x is equal to the opposite divided by the hypotenuse. We know the hypotenuse and we want to find the opposite. So now let's write this in the context of our triangle. We can say that sine 38 is equal to AB over 16. And so to find AB, we can do 16 multiplied by sine 38. And so putting this into our calculator, we'll find that AB is equal to 9.85 centimeters to 2 decimal places. And so we've used our trigonometric ratios to find that AB is equal to 9.85 centimeters. Now this question is worth 2 marks. We get the first mark for saying that sine 38 is equal to AB over 16. And we get the second and final mark for getting the correct answer of 9.85 centimeters to 2 decimal places. And so we've now achieved the full 2 marks needed in this question. In this question, we're told that Sally used her calculator to work out the value of a number y. The answer on her calculator display began 8.3, and we need to complete the error interval for y. And so if the answer on her calculator display began 8.3, we could have 8.3 followed by an infinite number of numbers. We could have something like 8.300004, and this still begins with 8.3. Or we could have something like 8.367928, which still also begins with 8.3. Or we could have 8.399918, which still begins with 8.3. And so we need to find the range of values for which the answer on her calculator display will begin with 8.3. And so the smallest value that will begin with 8.3 is just 8.3 itself. Anything smaller than 8.3 won't begin with 8.3. If we have something like 8.29, that begins with 8.2. And so the smallest number that can begin with 8.3 is just 8.3, with no numbers after the 3. And now to complete the error interval, we need to find the largest number that the calculator can display that still begins with 8.3. Let's look at the number we have here. We have 8.399918. Now this still begins with 8.3. If we had 8.39 recurring, this still begins with 8.3. But if we had 8.4, that doesn't begin with 8.3 anymore. Now looking at the error interval provided for us, we have a less than or equal to sign on the left hand side, and then we have a less than sign on the right hand side. Now since we have 8.3 on the left hand side, we said that y can be greater or equal to 8.3, and so we've included 8.3 in our error interval because 8.3 still begins with 8.3. Now we said that 8.39 recurring still begins with 8.3, but 8.4 doesn't begin with 8.3 anymore, and so we can put 8.4 on the right hand side. Because we have a less than symbol, we said that y is less than 8.4, but doesn't include 8.4, which means we've said that y can be 8.39 recurring, since this is still less than 8.4, but y cannot be equal to 8.4, which is exactly what we want, because 8.4 does not begin with 8.3. And so we've found that the error interval for y is that y is greater than or equal to 8.3, but less than 8.4. And so we get 1 mark for correctly finding 8.3 and writing this on the left hand side. And we get the second mark for correctly finding 8.4 and writing this on the right hand side, allowing us to get the full 2 marks needed in this question. In this question, we're told that £360 is shared between Abby, Ben, Chloe and Dinesh. The ratio of the amount Abby gets to the amount Ben gets is 2 to 7, and Chloe and Dinesh each get 1.5 times the amount that Abby gets. And now we need to work out the amount of money that Ben gets. So we're told that the ratio of the amount of money that Abby gets to the amount that Ben gets is 2 to 7, so we can write that down below. But now we're also told that Chloe and Dinesh each get 1.5 times the amounts that Abby gets, which means that their ratio will be 1.5 times greater than Abby's. And so 2 multiplied by 1.5 is equal to 3. And so using this information, we can say that the ratio of the amount Chloe gets to the amount that Dinesh gets is 3 to 3, because they both get the same amount. And so we can now say that the ratio of the amount Abby gets to the amount Ben gets, to the amount Chloe gets, to the amount Dinesh gets, is 2 to 7 to 3 to 3. Now we can total up the ratios, and so 2 plus 7 plus 3 plus 3 is equal to 15, and so this makes up 15 parts in total. Now since we're told that £360 is shared between the 4 people, we know that 15 parts equal £360. And so using this information, we want to find how much 1 part is worth, and so we can divide both sides by 15. 360 divided by 15 is equal to 24, and so 1 part is equal to £24. Now we need to find out the amount of money that Ben gets. Well, looking at the ratio, we can see that Ben gets 7 parts. If 1 part is worth £24 and Ben gets 7 parts, we can say that Ben gets 24 multiplied by 7, which is equal to £168. And so we've found out that Ben gets £168. Now this question is worth 4 marks. We get the first mark for saying that the ratio of the amount Chloe gets to the amount Dinesh gets is 3 to 3. We get the second mark for saying that the ratio of A to B to C to D is equal to 2 to 7 to 3 to 3, and totaling this to 15 parts. We get the third mark for finding out the value of 1 part, which is equal to £24. And finally, we get the fourth mark for recognising that Ben gets 7 parts, and so the amount of money that Ben gets would be equal to £24 multiplied by 7, which is equal to £168. And so we've now achieved the full 4 marks needed in this question. In part A, we need to write 0.00562 in standard form. The first thing that we can do is write down 5.62, because in standard form we need a number between 1 and 10, and when we have 0.00562, 5.62 is the only number that we can use. Now since we're writing in standard form, we know that we're going to have a times 10. And because we have a decimal number that's smaller than 5.62, we're going to have a negative power. Now to get from 5.62 to 0.00562, we divide by 1000, and so our power will be times 10 to the minus 3. And so we've found that 0.00562 in standard form is equal to 5.62 times 10 to the minus 3. Now in part B, we need to write 1.452 times 10 to the 3 as an ordinary number. Well, 10 to the power of 3 is equal to 1000, and so 1.452 multiplied by 1000 is equal to 1452. And so to get the 2 marks in this question, we get 1 mark for correctly answering part A, and for getting an answer of 5.62 times 10 to the minus 3. And in part B, we get 1 mark for getting the correct answer of 1452. Allowing us to get the full 2 marks needed in this question. In this question, we're told that the circumference of circle B is 90% of the circumference of circle A. And in part A, we need to find the ratio of the area of circle A to the area of circle B. Now we can draw a table to help us do this. Now there are different ways to approach this question. We could do this with algebra, or we could do this with numbers. We're going to try doing this with numbers, because numbers can be easier to understand. Well, now let's imagine that the circumference of circle A is equal to 10. Now if the circumference of circle B is 90% of the circumference of circle A, we want to multiply the circumference of circle A by 0.9. Because when we find 90% of something, it's equivalent to multiplying by 0.9. And so 10 multiplied by 0.9 would be equal to 9. And now this is where we need to be careful. We're asked to find the ratio of the area of circle A to the area of circle B. Now the circumference is equal to 2 pi r, and the area is equal to pi r squared. Since the scale factor of the circumference is equal to 0.9, the scale factor of the area would actually be equal to 0.9 squared. And so if we know the area of circle A, to get to the area of circle B, we want to multiply by 0.9 squared. Now let's imagine that the area of circle A is equal to 100. And 100 multiplied by 0.9 squared is equal to 81. And so we can now see that the ratio of the area of circle A to the area of circle B is equal to 100 to 81, which we can write down in our answer box. Now we need to apply a similar principle in part B. We're told that square E has sides of length E centimeters, and that square F has sides of length F centimeters. The area of square E is 44% greater than the area of square F, and we need to work out the ratio E to F, where E and F are the length of square E and the length of square F. Now we can use a very similar table to the table we used in part A, except this time we know the ratio of the area. So if the area of square E is 44% greater than the area of square F, to get from square F to square E, we want to increase by 44%, and when we increase by 44%, we want to multiply by 1.44. And so let's imagine that the area of square F is equal to 100. To increase this value by 44%, we want to do 100 multiplied by 1.44, which will leave us with 144. Now in part A, we had to square the scale factor to find the area. But in part B, we already know the scale factor for the area, and so the scale factor for the length would be the square root of the scale factor for the area. To get from the area of F to the area of E, we multiply by 1.44, and so to go from the length of square F to the length of square E, we multiply by the square root of 1.44. Now let's imagine that the length of square F is equal to 10. 10 multiplied by the square root of 1.44 is equal to 12. Now we need to find the ratio E to F, where E is the length of square E and F is the length of square F. And so the ratio of E to F would be equal to 12 to 10, and which we can simplify and say is equal to 6 to 5. And so the ratio E to F is equal to 6 to 5. Now this question is worth 4 marks. We get the first mark in part A for finding that the scale factor of the area would be 0.9 squared. And we get the second mark in part A for getting the correct ratio of 100 to 81. In part B, we get the third mark for finding that the scale factor of the length would be the square root of 1.44. And we get the fourth and final mark in part B for getting the correct answer that the ratio E to F is equal to 6 to 5. And so we've now achieved the full 4 marks needed in this question. In this question, we're told that Mary travels to work by train every day, and the probability that her train will be late on any day is 0.15. And in part A, we need to complete the probability tree diagram for Thursday and Friday. And now in order to complete this question, we need to know that the sum of the probabilities of all possible outcomes is always equal to 1. And now we can use this in order to find the probability that her train will not be late. So if the probability that her train will be late on Thursday is 0.15, as shown here in our diagram, we can say that the probability that the train is not late is 1 take away 0.15, because the total probabilities need to add up to 1. 1 take away 0.15 is equal to 0.85, and so we can say that the probability that her train will not be late on that Thursday is equal to 0.85. Now we need to fill in this tree diagram for Friday as well. But now we know that the probability that her train will be late on any day is 0.15. And so this means that the probability that the train will be late on Thursday is the same as the probability that the train will be late on Friday. And so our diagram for Friday will be exactly the same as the diagram for Thursday, because we know that the probability of the train being late is equal to 0.15, and so the probability that the train is not late will be equal to 0.85. Now in part B, we need to work out the probability that her train will be late on at least one of these 2 days. Now that we have our diagram here for reference, we can use this to find the probability that the train will be late on at least one of these 2 days. Now if the train is late on at least one of these 2 days, that means the train is late on either one day or both days. And so there are different possibilities to reach this outcome. The train could be late on Thursday, but not late on Friday. The train could be not late on Thursday, but late on Friday. Or the train could be late on both days. And so we need to consider the probabilities for all three events in order to find the probability that her train will be late on at least one of these 2 days. We can have the probability that the train is late and then not late, or not late and then late, or late and then late again. And so a general rule in probability is that when we see and, we multiply, and when we see or, we add. The probability that the train is late and not late on the next day is 0.15 multiplied by 0.85. Now the probability that the train is not late on Thursday and late on Friday is 0.85 multiplied by 0.15, and then the probability that the train is late on Thursday and late again on Friday is 0.15 multiplied by 0.15. And now since the probability that the train will be late on at least one of these 2 days is the first scenario, or the second scenario, or the third scenario, we can add the probabilities of these individual scenarios together. And so we have 0.15 multiplied by 0.85, add 0.85 multiplied by 0.15, add 0.15 multiplied by 0.15. And when we put this into our calculator, we'll get 0.1275, add 0.1275, add 0.0225, which will leave us with a final answer of 0.2275. And so we can say that the probability that her train will be late on at least one of these 2 days is equal to 0.2275. Now this question is worth 5 marks. We get the first mark in part A for doing 1 take away 0.15 is equal to 0.85. And we get the second mark in part A for having a fully correct tree diagram. We then get the third mark in part B for saying that the probability that her train will be late on at least one of these 2 days is the probability that the train will be late and then not late, or the probability that the train will be not late and then late, or the probability that the train will be late and then late again. Now we get the fourth mark for adding these 3 probabilities together. And we get the fifth mark for getting a final answer that the probability that her train will be late on at least one of these 2 days is 0.2275. And so we've now achieved the full 5 marks needed in this question. In this question, the group frequency table gives information about the times in minutes that 80 office workers take to get to work. And in part A, we need to complete the cumulative frequency table. Now cumulative frequency means that we add the frequencies as we go down the table. So it's an accumulation of all of the frequencies. And so between 0 and 20, we start with the same frequency of 5. But now between 0 and 40, we'd have to add the frequencies between 0 and 20 and 40. And so we'd do 5 plus 30, which gives us 35. And so between 0 and 60 minutes, we'll do 35 plus 20, which is equal to 55. And now between 0 and 80, we'll do 55 plus 15, which will give us 70. Between 0 and 100, we'll add the next number, so we'll have 70 plus 8, which is equal to 78. And finally, between 0 and 120 minutes, our cumulative frequency will be 78 plus 2, which is equal to 80. Now since our final cumulative frequency value is equal to 80, we can be pretty confident that we've gotten the correct answer, because the final cumulative frequency should always be equal to the total frequency, and we know that the total frequency is 80 because the table above gives information about the times that 80 office workers take to get to work. Now in part B, we need to draw the cumulative frequency graph to represent this information. We have our cumulative frequency table copied below. To start plotting this graph, we need the upper bound of the class width. The first class width is between 0 and 20. The upper bound would be equal to 20, and so we can plot this value against a cumulative frequency of 5. So we need to plot the coordinate 25. And so the next upper bound is equal to 40, and so we can plot this against a cumulative frequency to plot a point of 40, 35. The next points we'll plot is 60, 55. Then we'll plot 80, 70. Next we'll do 100, 78. And finally we'll plot the coordinates 120, 80. And to complete our cumulative frequency graph, we need to join these points together, starting from the origin. Well, now that we've drawn our cumulative frequency graph, in part C, we need to use this graph in order to find an estimate for the percentage of these office workers who take more than 90 minutes to get to work. Well, let's start by finding 90 on our x-axis. And so let's use a ruler to draw a vertical line from 90 up until the graph. And now we can draw a line across to find the cumulative frequency when t is equal to 90. Now looking across, we can see that the cumulative frequency when t is equal to 90 is equal to 75. And so this means that 75 people take less than 90 minutes to get to work. But we need to find an estimate for the percentage of these office workers who take more than 90 minutes to get to work. Well, if we know that 75 people take less than 90 minutes, and the total number of people is 80, we can say that the number of people who take more than 90 minutes to get to work is 80 take away 75, which is equal to 5. So now we've used our graph and we've found out that 5 people take more than 90 minutes to get to work. But in part C, we asked for an estimate for the percentage of these office workers who take more than 90 minutes to get to work. And so to find the percentage, we'll do 5 divided by the total of 80 multiplied by 100. And so we can say that an estimate for the percentage of these office workers who take more than 90 minutes to get to work is equal to 6.25%. Now this question is worth 6 marks. We get the first mark for a correct cumulative frequency table. We get the second mark for correctly plotting all of our points from our cumulative frequency table onto our cumulative frequency graph. And the third mark for a smooth line that joins these points together. We get the fourth mark for using the graph in order to find that the number of people who take less than 90 minutes is 75, and for therefore deducing that the number of people who take more than 90 minutes is equal to 5. We get the fifth mark for using this value in order to find a percentage by doing 5 divided by 80 multiplied by 100. And we get the last mark for getting a correct estimate that the percentage of these office workers who take more than 90 minutes to get to work is 6.25%. In this question, we're told that OAB is a sector of a circle with centre O and radius 7 cm. We're told that the area of the sector is 40 cm squared, and we need to use this in order to calculate the perimeter of the sector, giving our answer correct to 3 significant figures. Now there are 2 main formulae that we need to know about. The first is that the arc length is equal to theta over 360 multiplied by 2 pi r, and the second is that the sector area is equal to theta over 360 multiplied by pi r squared. Now we can call this angle theta. Now another thing that's important to remember is that the arc length is the line highlighted in blue. And so when we get to calculating the perimeter of the sector, we need to make sure to add the line OA and OB. Now since O is the centre of the circle, we can say that OA is a radius and OB is a radius, and so the radius of this sector is equal to 7 centimetres. Well, now that we know this, we can find out theta. And now once we find out theta, we can use this value to find the perimeter of the sector. Well, we're told that the sector area is equal to 40 centimetres squared. And so we can say that 40 is equal to theta over 360 multiplied by pi multiplied by 7 squared. And we did this using the formula for sector area. Well, now we can use our calculator to rearrange and to find theta. And so we've found that theta is around 93.54 degrees. Now let's use this in order to find the perimeter of the sector. Now remember that the arc length is just the line highlighted in blue. And so we can say that the perimeter of the sector is equal to the arc length plus the radius again. And given that the arc length is equal to theta over 360 multiplied by 2 pi r, we can say that the perimeter is equal to theta over 360 multiplied by 2 pi r plus r again. Now let's substitute in our values. We know that theta is around 93.54 degrees, and r is equal to 7. And so the perimeter is equal to 93.54 over 360 multiplied by 2 times pi times 7. And then all of this add 7 and add 7 again. And so putting these values into our calculator, we found that the perimeter of the sector is around 25.440 centimeters. And so remembering to give our answer correct to 3 significant figures, we can say that the perimeter of the sector is approximately 25.4 centimeters to 3 significant figures. Now this question is worth 4 marks. We get the first mark for finding the value of theta. We get the second mark for using this value of theta in order to find the arc length. We get the third mark for finding the perimeter of the sector by doing the arc length plus 7 plus 7. And we get the fourth and final mark for getting the correct answer that the perimeter of the sector is equal to 25.4 centimeters, correct to 3 significant figures. And so we've now achieved the 4 marks needed to get full marks in this question. In this question, we have a very scary looking expression which we need to simplify to ax minus b over cx minus d, where a, b, c and d are all integers. Now let's break this expression down. Let's start by looking at x squared plus 3x minus 10 over x minus 1. Now to begin to simplify this whole expression, let's start by factorising the numerator of this fraction. And so x squared plus 3x minus 10 can be written as x plus 5 multiplied by x minus 2. Well, now we can do x plus 5 divided by this fraction. And so this is how it was written in the question. We have x plus 5 divided by x squared plus 3x minus 10 over x minus 1. But now that we've factorised our fraction, we can write this differently. And so this is the same as writing x plus 5 divided by x plus 5 multiplied by x minus 2 over x minus 1. And so when we divide by a fraction, we flip the fraction on the right hand side and change the division sign into a multiplication sign. And so we can write this as x plus 5 multiplied by x minus 1 over x plus 5 multiplied by x minus 2. Now we can see that the x plus 5 will cancel out. And so we're left with x minus 1 over x minus 2. Well, now we can't forget about the 6, and so we need to do 6 plus x minus 1 over x minus 2. Well, now in order to add fractions, we need to make sure that the denominators are the same. And so to ensure that 6 has a denominator of x minus 2, we can write 6 as 6 multiplied by x minus 2 divided by x minus 2. And then remember to add the x minus 1 over x minus 2. Now that these two fractions have the same denominator, we can write this as 6 multiplied by x minus 2 plus x minus 1 all divided by x minus 2. And now the next thing that we need to do is to expand the brackets. 6 multiplied by x minus 2 is equal to 6x minus 12. And then we have the plus x minus 1 at the end. And so we're now left with 6x minus 12 plus x minus 1 divided by x minus 2. Well, we know that 6x plus x is equal to 7x, and minus 12 minus 1 is equal to minus 13. And so we can write this fraction as 7x minus 13 divided by x minus 2. And so we now have a final simplified answer of 7x minus 13 over x minus 2. Now this question is worth 4 marks. We get the first mark for factorising x squared plus 3x minus 10 over x minus 1 and getting an answer of x plus 5 multiplied by x minus 2 over x minus 1. We get the second mark for doing x plus 5 divided by this fraction to leave us with x minus 1 over x minus 2. We get the third mark for writing the number 6 with a numerator of x minus 2 and for saying that 6 is equal to 6 multiplied by x minus 2 divided by x minus 2. And we get the fourth and final mark for expanding and simplifying and for getting a final answer of 7x minus 13 over x minus 2, allowing us to get the 4 full marks needed in this question. In this question, we're told that a car moves from rest, and the graph gives information about the speed, v meters per second, of the car t seconds after it starts to move. And in part A, we need to calculate an estimate of the gradient of the graph at t equals 15. And now to do this, we need to draw a tangent of the graph at the point where t equals 15. And now the reason we need to draw a tangent is because this graph is a curve. We can't find the gradient unless we have a straight line, and so we can use this tangent in order to find the gradient. Now the gradient is a change in y divided by the change in x, and so let's find 2 points on our tangent that allows us to find the gradient. Now that we've found these 2 points, let's use it to find the gradient. The speed at this point is equal to 20, and the speed at the bottom is equal to 16. And then the time at this point is 17.5, and the time on the left-hand side is equal to 12.5. And so the change in y divided by the change in x is equal to 20 minus 16 divided by 17.5 take away 12.5. And putting these numbers into our calculator will leave us with an answer of 0.8. And so using our tangent, we found that an estimate for the gradient of the graph at t equals 15 is equal to 0.8. Now in the second part of part A, we need to describe what our answer to part I represents. Well, now the gradient is equal to the change in y divided by the change in x. We have speed on the y-axis and time on the x-axis. And so we can think of the gradient as the unit on the y-axis divided by the unit on the x-axis. Well, we know that the change in speed divided by the change in time is equal to the acceleration, and so we can say that the gradient of this graph represents the acceleration. Now in part B, we need to work out an estimate for the distance the car travels in the first 20 seconds of its journey, using 4 strips of equal width. Now the distance that the car travels can be found using the area under the graph. Now we want to find the distance in the first 20 seconds of its journey. And now to use 4 strips of equal width, each strip should have a width of 5. Now we can see that each strip is shaped like a trapezium, and although each strip isn't a perfect trapezium, we can use the formula for the area of a trapezium, since we're only finding an estimation for the distance that the car has travelled. We've copied the graph below for reference, and so we can use the formula for the area of a trapezium in order to find the area of each individual strip. Now we know that the area of a trapezium is equal to a plus b over 2 multiplied by the height. And now each strip has a height of 5. Now we need to find the values of a and b for each trapezium. And so we've drawn the lengths of each line on our graph. So we can see that the length of the first line is 4, the length of the second line is 12, the length of the third line is 18, and the length of the fourth line is 20. And so for the first trapezium, the area would be a plus b over 2 multiplied by height, which is 4 plus 0 divided by 2, all multiplied by 5, which will give us an answer of 10. And now the area of the second trapezium would be equal to 12 plus 4, all divided by 2, multiplied by 5, which will leave us with an answer of 40. Now the area of the third trapezium is equal to 18 plus 12 divided by 2, all multiplied by 5, which will leave us with an answer of 75. And finally, the area of the fourth trapezium is equal to 20 plus 18, all divided by 2, multiplied by 5, which will leave us with 95. And so now that we've found the area of each individual trapezium, we can add these all together in order to find an estimate for the distance the car has travelled in the first 20 seconds of its journey. And so the total distance would be equal to 10 plus 40 plus 75 plus 95, which leaves us with an answer of 220 metres. And so we've found that an estimate for the distance that the car has travelled in the first 20 seconds of its journey is equal to 220 metres. Now this question is worth 7 marks, so let's take a look at where each mark is allocated. We get the first mark for drawing a tangent to the curve at t equals 15. We get the second mark for using this tangent in order to find the gradient of the graph. And we get the third mark for finding a gradient of 0.8. We get the fourth mark in part AII for saying that the gradient of the graph represents the acceleration. Now we get the fifth mark for finding the area of each trapezium. We get the sixth mark for adding together all of the areas. And we get the seventh and final mark for getting the correct answer of 220 metres. And so we've now achieved the full 7 marks needed in this question. In this question, we need to make m the subject of the formula f equals 3m plus 4 over m minus 1. Now let's start by multiplying both sides by m minus 1, which leaves us with f multiplied by m minus 1 equals 3m plus 4. Now let's expand these brackets. F multiplied by m minus 1 is equal to fm minus f equals 3m plus 4. And then we're going to move the minus f over to the other side, which will leave us with fm equals 3m plus 4 plus f. Now since we want to make m the subject, we want to isolate the m's on one side, and so 3m can be moved to the other side, which leaves us with fm minus 3m is equal to 4 plus f. Well, now in order to make m the subject, we want to have m on its own, and so we can factorise m from the left-hand side. And so we'll have m multiplied by f minus 3 is equal to 4 plus f. And now to make m the subject, we need to divide both sides by f minus 3, which leaves us with a final answer that m is equal to 4 plus f divided by f minus 3. Now this question is worth 3 marks. We get the first mark for initially multiplying both sides by m minus 1. We get the second mark for rearranging and for isolating the m terms on one side, which left us with fm minus 3m equals 4 plus f. And we get the third and final mark for factorising m out of the left-hand side and for finding that m is equal to 4 plus f over f minus 3, allowing us to achieve the full 3 marks needed in this question. In this question, we're told that the straight line L has the equation 3y equals 4x plus 7, and the point A has the coordinates 3 minus 5. We need to find an equation of the straight line that is perpendicular to L and passes through A. Well, now let's start by writing the equation of line L in the format y equals mx plus c, and now in order to do this, we need to divide both sides by 3, and so we can say that y equals 4 over 3x plus 7 over 3. We need to find the equation of the straight line that is perpendicular to L, and so we need to find the perpendicular gradient. And now the perpendicular gradient is the negative reciprocal of the original gradient, and so the negative reciprocal of 4 over 3 is equal to minus 3 over 4. And so we can say that the gradient of the straight line perpendicular to L is minus 3 over 4. Well, now that we know the gradient of the straight line, we can say that y is equal to minus 3 over 4x plus c. But this is not a complete equation of the line because we need to find out the value of c. Now we can find c because we know that this straight line passes through the point A, and so given that this new line passes through A, we can substitute in the coordinates of A in order to find c. If y equals minus 3 over 4x plus c, we know that a point exists on this line where y is equal to minus 5 and x is equal to 3. And so we can say that minus 5 is equal to minus 3 over 4 multiplied by 3 plus c. Minus 3 over 4 multiplied by 3 is equal to minus 9 over 4, and so we can say that minus 5 is equal to minus 9 over 4 plus c. And so moving the minus 9 over 4 over to the other side, we've found that c is equal to minus 11 over 4. Now we've found the gradient of this new line, and we've found the value of c, which means we can form a complete equation of the straight line that is perpendicular to L and passes through A. And so we can say that the equation of this line is y equals minus 3 over 4x minus 11 over 4. Now this question is worth 3 marks. We get the first mark for finding that the original gradient of line L is equal to 4 over 3. We get the second mark for using this gradient of line L in order to find the gradient of the straight line that is perpendicular to L, and finding that this gradient is equal to minus 3 over 4. And we get the third mark for rearranging by using the coordinates of point A in order to find c, and for getting the final equation that y is equal to minus 3 over 4x minus 11 over 4, allowing us to achieve the full 3 marks needed in this question. In this question, we're told that there are some small cubes and some large cubes in a bag. The cubes are red or the cubes are yellow. The ratio of the number of small cubes to the number of large cubes is 4 to 7, and the ratio of the number of red cubes to the number of yellow cubes is 3 to 5. And in part A, we need to explain why the least possible number of cubes in the bag is 88. Well, now we need to think about what these ratios mean. If the ratio of the number of small cubes to the number of large cubes is 4 to 7, we have a total of 11 parts, because 4 plus 7 is equal to 11. And if the ratio of the number of red cubes to the number of yellow cubes is 3 to 5, we have a total of 3 plus 5, which is equal to 8 parts. Now the cube can either be small or large, and it can be red or yellow. You can have a small red cube or a small yellow cube, or a large red cube or a large yellow cube, which means that the two ratios need to be talking about the same number of parts, because the total number of small cubes and large cubes would have to be equal to the total number of red cubes and yellow cubes. And so to find the least possible number of cubes in the bag, we want the smallest number that allows the ratio of the number of small cubes to the number of large cubes, and the ratio of the number of red cubes to the number of yellow cubes to have the same total. And so what this question is really asking us to find is the lowest common multiple of 11 and 8 in order for the two ratios to have the same total. And so the least possible number of cubes in the bag is equal to 88 because the lowest common multiple of 11 and 8 is 88. We're now told that all of the small cubes are yellow. And in part B, we need to work out the least possible number of large yellow cubes in the bag. Now if we're looking for the least possible number of large yellow cubes, we need to work with the least possible number of cubes in total. Now from part A, we know that the least possible number of cubes is equal to 88, which means that in this part of the question, we're going to assume that the total number of cubes in the bag is equal to 88. Now we can use a two-way table to represent the information given to us. We know the total number of cubes in the bag, and we have the ratios between the number of small cubes and large cubes, and the number of red cubes to yellow cubes. Now let's work out some values before we can fill in our table. Now the ratio of the number of small cubes to the number of large cubes is equal to 4 to 7, and so the fraction of small cubes would be equal to 4 out of 11. And so to find the number of small cubes, we'd multiply this fraction by the total number of cubes. And so we can say that the total number of small cubes is equal to 4/11 multiplied by the total of 88, which gives us an answer of 32. Now we can apply the same principle to the number of large cubes. We can say that 7 out of 11 of the total number of cubes in the bag is the number of large cubes, and so the number of large cubes would be 7/11 multiplied by 88, leaving us with an answer of 56. Now looking at the ratio of the number of red cubes to the number of yellow cubes, well 3 plus 5 is 8, and so we can say that 3 out of 8 of the total number of cubes would be equal to the number of red cubes, and so the number of red cubes would be 3/8 multiplied by 88, giving us an answer of 33. And finally, we can say that the total number of yellow cubes is equal to 5/8 multiplied by 88, giving us an answer of 55. Now let's put these values into our two-way table. We said that the total number of red cubes is equal to 33. We said that the total number of yellow cubes is equal to 55. The total number of small cubes is equal to 32. And the total number of large cubes is equal to 56. We also know that the number of all cubes in total is equal to 88. Now we're told that all of the small cubes are yellow, which means that we can say out of the small column we have 32 yellow small cubes and 0 red small cubes. Now let's look across the table. We know that the total number of red cubes is equal to 33. There are 0 small red cubes, and so there must be 33 large red cubes in order to make up for the total of 33 red cubes. Now we know that the total number of yellow cubes is equal to 55. There are 32 small yellow cubes, and so the total number of large yellow cubes must be equal to 55 take away 32, leaving us with an answer of 23. Now part B asked us to work out the least possible number of large yellow cubes in the bag. Looking at our table, we've found that the number of large yellow cubes is equal to 23. And so we can say that the least possible number of large yellow cubes in the bag is equal to 23. Now this question is worth 4 marks. We get the first mark for saying that the least possible number of cubes in the bag is equal to 88 because the lowest common multiple of 11 and 8 is equal to 88. We get the second mark for drawing a two-way table which can help us to represent the information given to us. We get the third mark for finding the total number of small cubes, large cubes, red cubes and yellow cubes. And we get the fourth and final mark for using the information we found in order to find that the least possible number of large yellow cubes in the bag is equal to 23, allowing us to get the full 4 marks needed in this question. In this question, we're told that the points A, B, C and D lie on a circle. CDE is a straight line. We're told that line BA is equal to BD, CB is equal to CD, and angle ABD is equal to 40 degrees. We need to work out the size of angle ADE, giving a reason for each stage of our working. Now let's start by looking at triangle BAD. We know that the line BA is equal to the line BD, and so we can say that triangle BAD is isosceles. Now in an isosceles triangle, we know that the base angles are equal. We also know that angles in a triangle add up to 180 degrees. Now if the base angles are equal, angle BAD is equal to angle BDA. Now given that angles in a triangle add up to 180 degrees, we can say that angle BAD, or angle BDA, is equal to 180 take away 40, all divided by 2, giving us an answer of 70 degrees, which we can now label in our diagram. Next we can move on to the quadrilateral ABCD. Now the quadrilateral ABCD is a cyclic quadrilateral, because all 4 points lie on the circumference of the circle. Using our knowledge of circle theorems, we know that the opposite angles of a cyclic quadrilateral is equal to 180 degrees. Angle BAD and angle BCD are opposite angles in a cyclic quadrilateral, and so we can use this in order to find BCD, because we already know what BAD is. So we can say that angle BCD is equal to 180 take away 70, which is equal to 110 degrees, which we can also label in our diagram. Next we can look at the triangle BCD. We're told that the line CB is equal to the line CD, and so we can say that triangle BCD is isosceles. Now given that triangle BCD is isosceles, we know that the base angles, angle CBD and angle CDB, are equal. And so we can say that angle CBD is equal to angle CDB, which is equal to 180 take away 110, all divided by 2, which is equal to 35 degrees. And so we can add this to our diagram. Now finally, we can use all the information that we found in order to find angle ADE, which we've labelled as theta on our diagram. We're told that line CDE is a straight line, and we know that angles in a straight line add up to 180 degrees. Now we can use this to find angle ADE. Now on the straight line, we have 35 degrees, 70 degrees, and theta. We know that all 3 of these angles must add up to 180 degrees. And so we can say that angle ADE is equal to 180 take away brackets 35 plus 70, close brackets, which is equal to 75 degrees. And so we've found that the size of angle ADE is equal to 75 degrees. Now this question is worth 5 marks, so let's take a look at where each mark is allocated. We get the first mark for saying that angle BAD is equal to angle BDA, which is equal to 70 degrees. We get the second mark for the correct justification, and this is because base angles are equal and angles in a triangle add up to 180 degrees. We get the third mark for saying that opposite angles of a cyclic quadrilateral are equal to 180 degrees. Now we get the fourth mark for using this fact in order to find that angle BCD is equal to 110 degrees. And we get the fifth and final mark for finding angle CDB and for using the fact that angles in a straight line add up to 180 degrees, and for therefore finding that the size of angle ADE is equal to 75 degrees, allowing us to get the full 5 marks needed in this question. In this question, we're given a diagram which shows a triangular prism. The base ABCD of the prism is a square of side length 15 centimeters. Angle ABE and angle CBE are right angles, and we're told that angle EAB is 35 degrees. We're then told that M is the point on DA, such that the ratio DM to MA is equal to 2 to 3. Using this information, we need to calculate the size of the angle between EM and the base of the prism, giving our answer correct to 1 decimal place. Now we can first start by looking at the length DA. We're told that the ratio DM to MA is equal to 2 to 3, and so we can use this in order to find the length DM and the length MA. Now 2 plus 3 is equal to 5, And so we can use this ratio to say that dA is split into 5 parts. The ratio tells us that dm has 2 of these 5 parts, and ma has 3 of these 5 parts. And so using the fact that dA is 15 centimeters, we can use this to find the length of dm and ma. We can say that dm is equal to 2/5 of 15, which is equal to 6 centimeters. And then we can say that ma is 3/5 of 15, which is equal to 9 centimeters. Now let's put this back into the bigger diagram. Here we have a copy of the original diagram, and you can see that we've highlighted a triangle. We're asked to find the angle between EM and the base of the prism, and the angle labelled theta is the angle that we need to find. And so you might notice that we need to find the length EB and the length MB in order to find this angle. Let's take a look at triangle ABE. Now ABE is a right angle triangle, and we can use this to find the length of AB because we're given one side length and one angle. Now using our knowledge of SOHCAHTOA, we have the opposite side and the adjacent side. We know that tan is equal to opposite over adjacent, and so we can say that tan 35 is equal to EB over 15. And so the length EB is equal to 15 multiplied by tan 35, which is equal to 10.5 centimeters to 1 decimal place. Now that we've found length EB, we can try to find the length MB, and we can do this by looking at the triangle MAB. Now MAB is another right angle triangle. Now we can use Pythagoras in order to find the length MB, since we know the length MA and the length AB. Pythagoras' theorem states that a squared plus b squared is equal to c squared, and so in this case, 9 squared plus 15 squared is equal to MB squared. And so we can say that the length MB is equal to the square root of 15 squared plus 9 squared, which is equal to the square root of 306. And it's best to leave this value in its exact form. So we've found the length EB, which is 10.5 centimeters to 1 decimal place, and we've found the length MB, which is root 306. And now we can use this information to find theta. Take a look at triangle EMB. Now since EMB is a right angle triangle, we can use our trigonometric ratios in order to find theta. We can say that tan theta is equal to opposite over adjacent, and so tan theta is 10.5 divided by root 306. Now using this, we can say that theta is the inverse tan of 10.50 ... divided by the square root of 306. And putting these values into our calculator, we'll find that theta is equal to 31.0 degrees to 1 decimal place. And so we've now correctly calculated the size of the angle between EM and the base of the prism, which is equal to 31.0 degrees to 1 decimal place. Now this question is worth 4 marks. We get 1 mark for using the ratio to find the length DM and the length MA. We get the 2nd mark for finding the length EB. We get the 3rd mark for finding the length MB. And we get the 4th mark for using our trigonometric ratios and the values that we've found in order to find the angle between EM and the base of the prism, which we've correctly found to be 31.0 degrees to 1 decimal place, allowing us to get the full 4 marks needed in this question. In this question, we're told that CDEF is a quadrilateral. The vector CD is equal to A, the vector DE is equal to B, and the vector FC is equal to A minus B. And in part A, we need to express the vector FE in terms of A and or B, giving our answer in its simplest form. Now let's mark the vector FE on our diagram. Now the blue line shows how we can get from F to E, but just using that blue line, we can't express the vector FE in terms of A or B. So let's see if we can figure out an alternative route to get from F to E. Well, to get from F to E, we can start by going from F to C. Then we can go from C to D. And finally, we can go from D to E. Well, now we have enough information to express the vector FE in terms of A and or B. We know that the vector FE is equal to FC plus CD plus DE. Now using the information given to us in the question, we can say that the vector FE is equal to A minus B, because FC is equal to A minus B, plus A, because the vector CD is equal to A, and plus b, because the vector DE is equal to b. Now let's simplify this by collecting like terms. We have a plus a, which is equal to 2a, and then we have minus b plus b, which is equal to 0, leaving us with a simplified vector of 2a. And so we've found that the vector FE is equal to 2a in its simplest form. Now we're told that M is the midpoint of DE, and X is the point on the line FM, such that the ratio Fx to Xm is equal to n to 1. We're also told that CXE is a straight line. And in part B, we need to work out the value of n. Let's start by finding the value of the vector Fm. And we can use our diagram to help us. So to get from F to M, we can start by going from F to C. Then we can go from C to D. And then we can go from D to M. Now since we're told that M is the midpoint of DE, the vector dm would be half of the vector DE. We know that the vector DE is equal to b, and so the vector dm must be equal to half b. And so we can say that the vector Fm is equal to Fc plus Cd plus dm, which is equal to a minus b plus a plus half b. And we can simplify this by collecting like terms. A plus a is equal to 2a, and minus b plus half b is minus half b, and so the vector Fm is equal to 2a minus half b. Now let's see what this means in terms of our ratio, and we can use a diagram to help us. Well, we have the line Fm in front of us, and x lies in this point, such that the ratio Fx to Xm is equal to n to 1. Now using this ratio, we can say that there are a total of n plus 1 parts. And so we know that Fx has n of these parts, and Xm has 1 of these parts. Now given that the total value, Fm, is equal to 2a minus half b, and Fx has n of these parts, we can say that the value of Fx is n over n plus 1, multiplied by the total of 2a minus half b. And so applying the same principle to Xm, we know that Xm has 1 over n plus 1 parts, and so we can say that the value of the vector Xm is 1 over n plus 1, multiplied by the total of 2a minus half b. Well, now we're also told that CXE is a straight line, and so because CXE is a straight line, we can say that the vector CX is parallel to the vector CE. That might not seem important right now, but we'll need that information later. Now let's take a look at the vector CX. Now to get from C to X, we can start by going from C to F. And then we can go from F to X. And so we can say that the vector CX is equal to CF plus the vector FX. We're told that FC is equal to A minus B, and so CF would be the negative of this. And so CF is equal to minus brackets A minus B. Now we need to add Fx, and we said that the vector Fx is equal to n over n minus 1 multiplied by 2a minus half b, which we can now add on to our vector Cx. Well, now we have a lot of simplifying to do. Let's start by expanding the first set of brackets, and so minus brackets a minus b, we can imagine that this minus sign is equal to minus 1. And so minus 1 multiplied by a would be equal to minus a, and minus 1 multiplied by minus b would be equal to positive b. And so the first set of brackets simplifies into minus a plus b. Then we need to expand the second set of brackets, and we have n over n plus 1 multiplied by 2a minus half b. Well, first of all, 2a multiplied by n over n plus 1 would become 2n over n plus 1 a. And minus half b multiplied by n over n plus 1 would become minus 1 over 2 lots of n plus 1 b. Now you'll notice that we have some circles in blue and some circles in orange, and what we're doing here is collecting like terms, because we want to group the a's together and the b's together. We'll start with the blue circles. Well, minus a plus 2n over n plus 1 a can become minus 1 plus 2n over n plus 1, all multiplied by a. Now looking at the orange circles, b minus n over 2 lots of n plus 1 b can be simplified into 1 minus n over 2 lots of n plus 1, all multiplied by b. Now we need to add these fractions, and when we add fractions, remember that we need a common denominator. Now let's first start by looking at the terms of a. We need to do minus 1 plus 2n over n plus 1. We need to express minus 1 with a denominator of n plus 1. And so minus 1 can be written as minus brackets n plus 1 all over n plus 1. And so we can say that minus 1 plus 2n over n plus 1 can be written as minus brackets n plus 1, close brackets, plus 2n all over n plus 1. Now let's do the same thing for the terms for b. We have 1 minus n over 2 lots of n plus 1. Now to make these have a common denominator, we need to express the number 1 so that it has a denominator of 2 brackets n plus 1. And so we can just say that 1 is equal to 2 brackets n plus 1 divided by 2 brackets n plus 1. And so we can write 1 minus n over 2 lots of n plus 1 as 2 lots of n plus 1 minus n all divided by 2 lots of n plus 1. Well, now let's expand these brackets. Minus brackets n plus 1 becomes minus n minus 1, and then don't forget the 2n, all over n plus 1. And now to expand the second set of brackets, we have 2 multiplied by n plus 1, which becomes 2n plus 2, and then the minus n, all divided by 2 lots of n plus 1. Now we can simplify this even more. Minus n minus 1 plus 2n can be written as n minus 1, and so the vector cx is equal to n minus 1 over n plus 1 a. Now looking at the terms for b, 2n plus 2 minus n is the same as n plus 2, and so the terms for b becomes n plus 2 divided by 2 lots of n plus 1 b. Now earlier we said that CXE is a straight line, and so CX is parallel to CE. And so because they're parallel, we can say that the vector CX is a multiple of the vector CE. Now looking at our diagram, we can say that the vector CE is equal to CD plus DE, which is equal to A plus B. CE is equal to A plus B, and so it's really important to note that the coefficient of A is equal to the coefficient of B. And so we need to pick up on the fact that because CX is parallel to CE, the same principle applies to CX. And so for the vector CX, the coefficient of A must be equal to the coefficient of B. Now we know that the vector Cx is equal to n minus 1 over n plus 1 a plus n plus 2 over 2 lots of n plus 1 b. We said that for the vector Cx, the coefficient of a is equal to the coefficient of b, and so we can say that n minus 1 over n plus 1 is equal to n plus 2 over 2 lots of n plus 1. Now we can begin to simplify to solve for n. Now we have n plus 1 in both denominators, and so these cancel out. And so we're left with n minus 1 is equal to n plus 2 over 2. Now we can multiply both the left-hand side and the right-hand side by 2. And so we can say that 2 lots of n minus 1 is equal to n plus 2. Expanding these brackets, we can say that 2n minus 2 is equal to n plus 2. And we can move the n over to the left-hand side by taking away n from both sides, leaving us with n minus 2 is equal to 2. We can move the minus 2 from the left-hand side to the right-hand side by adding 2 to each side, and so we're left with n is equal to 4. And so we've now completed part B and found that n is equal to 4. Now this question is worth 6 marks. We get the first mark in part A for saying that the vector FE is equal to A minus B plus A plus B. And we get the second mark for simplifying this vector and for saying that the vector FE is equal to 2A in its simplest form. We get the third mark in part B for a process to find the vector FM and for saying that the vector FM is equal to 2A minus half B. We get the fourth mark for a process to find the vector CX. We get the fifth mark for saying that n minus 1 over n plus 1 is equal to n plus 2 over 2 lots of n plus 1. And finally, we get the 6th mark for rearranging and simplifying, and for saying that n is equal to 4, allowing us to achieve the full 6 marks needed in this question.